Okay, so now we're ready to start talking about arrays. And for example, let's say I wanted to write a program. I just have a console app here for starters. If I want to write a program to store the colors of the rainbow, okay, the 7 colors, I could just create 7 variables. I have 3 going here. I could create 4 more, 7 separate variables, string variables, and put the colors into those variables. But there's really a better way to do this, especially when you're storing a group of kind of related items like we're doing here. The better way to do this is to put those items into an array, and then they're all stored together in memory, one after another in contiguous memory locations, as opposed to having them scattered in 7 variables all over the place. So I have a visual here for you. Let me pull up this Word document. And rather than having 7 separate variables, I'm going to create an array called colors. And if you can visualize this in memory, we'll have 7 slots. So these are called elements. So this will be an array of 7 elements in memory. And it'll be an array of type string, because you can't mix and match data types in an array. It's like they're all going to be strings, or they're all going to be ints, or they're all going to be decimals. So we'll do an array of type string, 7 elements in size. And we have to differentiate between the different elements of the array. So each element is indexed. These are called indexes. Sometimes you hear that referred to as a subscript. I'd like you to know both terms. I typically just say index, but some textbooks I notice say subscript. But in any case, the indexes are 0-based, so you need to get used to that because we start counting at 1 naturally. We have since preschool, so that's kind of hard to make that shift. But as a programmer, from now on, you start counting at 0. And we're going to start our loop counters at 0, you'll see. So, yeah, so and just, again, there's that kind of offset. So even though this array has 7 elements, the highest index is 6 because we start counting at 0. So just something that you'll have to become accustomed to. So anyway, let me get to the code here. So we're going to wipe these out because we don't want to do it that way. And what I'll do is create an array of type string. You're going to see some new syntax here. This is array notation where you see the square brackets. Okay, so this is me letting the compiler know I'm going to create an array of type string. If it were just this without the square brackets, then that would just be a regular string variable, which we don't want. Okay, so I'm going to name my array colors. And this is the syntax here that you need to finish off the statement. This, especially this keyword new, that's going to make a lot more sense in the coming weeks when we start talking, really digging into object-oriented programming. So just kind of take it on faith for now that this is the syntax that you need. So this will create an array of 7 elements. Notice the 7 there, that is the number of elements, obviously. So now I have an empty array. Okay, so if you want to imagine an empty array, just imagine like almost like an empty egg carton. If somebody cut out an egg carton of 7 slots in the egg carton, that's what we have now. We have a container with nothing in it. So now I want to populate my array with the actual colors. So we talked about the fact that you have to differentiate between the elements, and you use their indexes or subscripts to do that. So if I want to put the color red into that first element in my array, I have to use the index of 0 because those are, as we said, 0-based indexes. So I'm just going to zip through the entire array, element by element, adding the colors, changing the indexes. Okay, so now my array is fully populated, and it looks like this in memory, basically. That's what it's going to look like. Okay, so now I want to show you the whole point of putting these the data into the array is to maybe get it back out. Maybe you want to print it at the console or something. And to do that, let me just show you what not to do, okay? You might be tempted to say, oh great, I have this array, it's populated with colors. Let me just print that colors array to the console. Seems like a good idea. Let's go ahead and run that and see what we get. Okay, this is what we got. Clearly not what I was hoping to see. Okay, so it did not print the contents of the array. It just basically printed this generic statement of that there's this array of type string. So that's how not to print contents of an array. What you want to do is you're going to loop through the array element by element, printing the values to the console. Arrays and loops go hand in hand, okay? Why don't we use the for loop? We could just as easily use a while loop, but I'm going to use a for loop to loop through this array. So we're going to say for int, and then I have to come up with a loop counter. That much hasn't changed. I'll just go with little I, kind of a throwaway name. The initial value of your loop counter has got to start at 0. And the reason is we want the value of our loop counter, the values as the loop is looping, we want those values to coincide perfectly with the array indexes, and those array indexes start at 0. So you want to start, whenever you're looping through array, you've got to start counting at 0. Okay, and so we're going to keep going while I is less than. I can just hard code a 7 here, or I can say less than or equal to 6. Okay, I'll show you a better way to do that. But for now, let's just to drive home that we want these indexes, the values of the loop counter match the indexes perfectly. So I'll just hard code a 6 there. So you know we're starting at 0, we're stopping at 6, which coincidentally are the indexes for the array. And then obviously we need the increment here. So now this is going to be a single body or a single statement in the loop body, so I don't need curly braces here. So I'll just do a quick console write line. Let's say I want to print the colors like a shopping list, okay, with red at the top and violet at the bottom. So all I can have to do is reach into that array, and then very importantly, this is a very important technique, we're going to use the loop counter as the array index. Okay, I'm going to put this in all caps. Loop counter as array index. Very, very important technique, very common thing to want to do in programming. So think about this. First time through the loop, I has a value of 0, okay, and so it's going to reach right into that colors array at the index of 0 and print red, okay. Second time through the loop, I has been incremented up to 1. So now it's going to reach right into the array at the index of 1 and print the orange, and so on and so forth, okay, through the end of the array, and finally we get the violet. Okay, so let's go ahead and run that. Okay, and there you have it. We have our colors printed to the console. Okay, just one more quick technique in this video. I want to talk about this. I hard-coded the 6 because we have 7 elements in the array and the highest index is 6. So we're going to keep going while the loop counter is less than or equal to 6. However, there is a better way to do this. And let's say this was not a rainbow and I was going to maybe add some more colors to this. Like aqua and magenta and so on. So I don't want to be limited. I don't want that hard-coded 6. Every time I add a new color or change the size of the array, then I'm going to have to pick through the code and change these hard-coded numbers here. So a better way is to kind of leave it open-ended, and we can do that. If we say we're going to keep going while I is less than colors dot length. The length property of an array reflects the length of the array in elements. So this is 7 elements in length. So we're going to keep going while I is less than 7, okay, which gets us our highest value of 6 for the loop counter, which coincides perfectly. So if I were to add another color here, then everything would just fall into place. I don't have to touch the loop because I don't have a hard-coded value there. And kind of along these lines, it's probably more common to do something like this. Okay, so I'll create a const. That's like a variable whose value is locked down and I can't come along and change it. But I'll create a variable called size. I'll put a 7 in there, and I'll initialize this to size. So again, I don't have a hard-coded 7 there. So if I decide, hey, you know what, 7 colors isn't enough, maybe I want to do like a Crayola box of 64 colors, all I have to do is change this one number here, and the rest of the program is going to fall into place. Obviously, I'd have to populate the rest of the slots in the array, but you know, no hard coding here, no hard coding here. I don't have to worry. It's almost like a maintenance-free program in that regard, just taking that small step at the outset, and then it saves me a lot of work in the long run. Because keep in mind, like, this is a tiny program, but in the real world, programs can be thousands, if not millions, of lines of code. Do you really want to have to pick through and change all these hard-coded values if there's a small change in the size of an array somewhere? Do you want to pick through a program that's thousands of lines of code? Of course you don't. So just taking these small measures is a good investment up front to save yourself a lot of time later.